Welcome to Subnetting Level 1, Introduction to Binary Numbers. Before we can start talking about subnetting and IPv4 addressing, we need to understand binary numbers and how they relate to the decimal number system. So that's where we're going to start. The decimal number system is also called base 10. The base is the number of digits in the system. So base 10 uses 10 digits, 0 through 9. Let's take a look at the base 10 placeholders. In the number 2,548, you'll see that the 8 is in the ones place. That's actually derived by taking the base and raising it to the 0 power. Anything raised to the 0 power is 1. To get to the next placeholder, we simply take a look at the base again, but we raise that to the power of 1. That gives us the tens place. And likewise, the next placeholder is 10 to the power of 2, and the next 10 to the power of 3. So once again, that's how we get the ones place, the tens position, the hundreds position, and the thousands position. Now, any number system works like that. So when we talk about computers, we need to realize that computers don't really work in a base 10 environment. Computers function using the base 2 number system, which is also known as the binary number system. A binary number system uses only the values of 1, which is the on state, and off, which is represented by the number 0. So that's why when you look around and you see power switches on everything, they no longer even use the words on and off. They more frequently just use a 1 and a 0 to represent the power state. So now let's take a look at that binary system. The binary system, as we mentioned, is called base 2. It uses the two digits 0 and 1. And sometimes we'll see a binary number represented with the superscript of 2. I should say the subscript, it's below the subscript of 2. That's so we don't get confused when we look at a number and wonder, oh, is that a binary number or is it actually a decimal number? So let's take a look at the base 2 placeholders. Once again, the first position is the ones position, but we're starting with the base 2. So 2 raised to the 0 power, of course, again, is 1. Then we're going to take 2, the base, raise it to the first power, which is 2. 2 raised to the second power, like 2 squared, is 4. And 2 raised to the third power is 8. Those are our values within the placeholders. They become important when we try to relate the binary system to the decimal system. If you can imagine having to look at ones and zeros all day and make sense of them, figuring how they represent numbers and letters, it would be very confusing for you and me. So what we do is we learn how to convert binary numbers into their decimal equivalents. So let's see how that's done. Here's the first example. On the screen is a binary number, 1010. So our task is to convert this binary number to its decimal equivalent. So the first step in the process is write the values under the placeholders. So remember, we have a 1, 2, 4, and 8. This is a good thing to memorize. Always start with the ones place, but in the binary system, it's kind of easy to remember because you simply have to double things. So 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 4 is 8. So you can double those. Then the next step is after you write the values under the placeholders, you simply look for the ones and ignore the zeros. And by that, any place where there's a 1, pay attention to the values below it, and the zeros you can just ignore. Then we take those two numbers, in this case the 8 and the 2, and we add them together, and that gives us our decimal equivalent. So what that means is that base 10, this number, this number in binary, 1010, binary number, is equal to 10 in base 10. All right, let's try it again. We're going to convert this number, 0110. It's a binary number, and we want to see what it's equal to in its decimal value. So write the numbers under the placeholders, 1, 2, 4, 8. Look for the ones, ignore the zeros, and now add those two numbers together. 4 plus 2 is 6, and 6 would be our answer. All right, example number 3. Hopefully this is getting a little bit easier now. So convert this binary number 1101 to its decimal equivalent. Write the values under the placeholders. Look for the ones, ignore the zeros. In this case, we have 3 ones, 3 bits that are in the 1 position. So we have to do 8, 4, and 2. 8 plus 4 plus 1 is 13. All right, now here it's time for you to practice. If you want, you can pause your video and compute these. Just grab a piece of scratch paper, compute them, find out what the answer is if you take these binary numbers and find their decimal equivalents. And then when you're done, restart the video. I'm going to go ahead and work these problems. So the first binary number is 0011. So I start with my placeholders again. I'm going to write those down below. So 1, 2, whoops, sorry about that. And I have a 2 here, I have a 4 here, and I have an 8 here. So I look for the ones. I have really have to focus just on the 2 and the 1. So remember 2 plus 1, the answer would be 3. In this second binary number, there's only a 1 in this place right here with the 8. So the answer is 8. The next number is 0010. There's only a 2 here, so the answer is 2. And in the last place, I have an 8, a 4, a 2, and a 1 that I have to write down for my values. And I see that they're all ones. So I'm going to have to add all of those numbers together. So 8 plus 4 plus 2 plus 1, and that equals 15. All right, well, I hope that went well for you. You have completed subnetting level 1. Good luck. You're on your way.